Hello everyone, I will be going through the general rules of significant figures in chemistry. Let's start with the easiest rule, 123 and 12.17. All numbers that aren't zeros count as a significant figure. So this just becomes 3, significant figure. This becomes 4, significant figure. Number 2, any zeros in between the numbers that aren't zero also count as a significant figure. So 10,001, this zeros in between all count is 3, and these numbers also count. 5 becomes 5 significant figures. The decimals in between also does not change anything, and 0 in the middle counts, and the integers count. It becomes 4 significant figures. Number 3, any zeros in the front do not count, or trailing zeros is also what it's known as 0.01 and 0.000001. These zeros in the front does not count at all. So only 1 is left for both of them, which means both of them has 1 significant figure. Number 4, any scientific notation can be ignored. For example, 10 to the power of 3, those can be ignored. And these have 2 significant figures, so that just becomes 2 significant figures. Number 5 has 2 cases. Number 1, when it has no decimal points. If it has no decimal points, the zeros in the back do not count. So both of these just becomes 2 significant figures. It's very simple. However, when there are decimal points, these zeros count as significant figures. So this becomes 3 significant figures, while this becomes 4 significant figures. For multiplication and division, you always have to round up to the smallest significant point, significant figures. So 2 times 2.2, these become 4.4. However, this has 1 significant figure, so you have to round this to 1 significant figure, which becomes 4. Same for division, 1.1, but since it has 1 significant figure, you have to round up to 1, which is 1 significant figure. For addition, you have to add up to the smallest decimal point. That becomes 4.42. However, this is 1 decimal point, so you have to round up to 1 decimal point. I'll explain more of this as we solve the problems. Number 1, the trailing zero does not count, and the integers in the back counts 3 significant figures. Any zeros in the middle counts, that's 3. And these numbers count, so that becomes 5. This leading zero does not count when there are no decimals, so that becomes 2 significant figures. This one, any trailing zero does not count. Zeros in between count, and the numbers count. It's 3 significant figures. Number 8 can be confusing, however, the numbers count, the zero in between counts, the integers count, and if they're a decimal, the leading zero counts as 6 significant figures. For 10, scientific notation, you can just ignore. 1 significant, 2 significant figure, there's a decimal, so these count, it just becomes 4 significant figures. Let's look at the calculations. Number 12, these have 2 significant figures, 3 significant figures, and 4 significant figures. You always have to round up to the smallest significant figures. This equation gives us around 4.8069. However, we round up to 2 significant figures, which will be 4.8 centimeters cubed. Include your units. Number 13, if you add all of these up, it becomes 338.271. If you look at the one with the lowest decimal point, it's 141 with 0 decimal points, which means that we also have to round up the answer to 0 decimal points, which becomes a whole number, 338 liters. Number 15, this might look confusing because there's also division and multiplication, but it's the same. This becomes 2 significant figures, which is the smallest. And if you just calculate this number, it becomes 17.7889. But multiplication and division always rounds up to 2 significant figures, with the smallest significant figures, which is 2 in this case. So it just becomes 18 m squared over seconds. This m squared over seconds is just a unit. Thanks for listening.